Hey guys, Mr. Shaw here. We're going to be talking about transformations of quadratic functions today. It's going to be nice and easy. We've already actually kind of talked about it. So we're going to talk about just go a little bit more in depth with it, and then of course we're going to learn how to go from standard form into vertex form. Alright, so let's do it. Again, learning objectives, you're going to write quadratics in vertex form, and we're going to talk about transformations of quadratics in vertex form. Little vocab, again, you guys know vertex form is y equals a times x minus h squared plus k. And you guys know the transformations usually have to do with, again, if you are talking about vertex form, with the a value. Okay, that's going to tell you if it's going to be a stretch. Okay, if a is greater than 1, or a compression. Okay, if a is between 0 and 1. Okay, most often it's a fraction. Okay, and then again here, this is the h value. This will be your horizontal shift. And then the k value is your vertical shift. It's a terrible vertical, I'm sorry, moving on. Okay, and that's pretty much it. That'll pretty much cover it. Oh, and then there's one more. If a is negative, negative a, it means that the graph is facing down. You guys should already know this. Just reviewing with you. Alright, so again, we got vertex form here. Let's just review. Again, you guys see here, we're talking about the inside number is always the x value, but opposite. It's really wherever this equals 0. So again, it equals 0 at 3. So my vertex here is going to be positive 3 comma negative 5. And a is going to equal whatever's in front of the x. So in this case, it's 1. So let's go to our vertex. It'll be 3 comma negative 5. And then again, we're going to do our 1a and 3a. So 1a, so 1 times 1 is 1. And 3a, 3 times 1 is 3. So we'll go over 1, up 1, and then over 1 and up 1, 2, 3. Over 1, up 1, over 1, up 1, 2, 3. And here we go. That's kind of bad. Let me try again. Not too bad. A little better. Guys, I'm sorry. I wish you knew how hard this was. Here we go. All right, there we go. That looks good. Okay, so again, we're going to do the same thing here. Again, and again, there's no, we could say that the shift anyway would be, obviously from 0, 0, we went right 3 and then down 5. Okay, from the parent graph, but we didn't stretch or compress it or anything like that. So let's look at the next one. Again, in this case, our vertex is, again, inside's opposite, so negative 2 comma 3. So negative 2, positive 3 right here. And you see a is equal to negative 2. So that's going to make our a values a little bit different. We know it's going to be facing down, and it's going to be stretched, okay, because the 2 is greater than 1. All right, so again, I've got 1a here is going to be 1 times negative 2 is negative 2, and 3a is going to be negative 6. So again, you always go over 1. So I'm gonna go over 1 and down 2 on both sides, and then over 1 and down 6. So right here and right here. And here is our parabola. There you go. All right, so again, we're going to talk a little bit. We're going to do a lot more stuff with the vertex form, but again, we're going to talk. In this case, we're going to do maximum minimums now, and then we'll go from there. Okay, this will be a little bit like what we did last time, but we'll talk. And again, I don't like this. Let's not shrinking. Let's compressing. I don't know why that's there. All right, so let's go ahead and we'll just name it off. So again, the vertex here is going to be 3 comma negative 5, and a is just 1. So again, we know that we're going to, in order to, from 0, 0, we're going to go to the right 3 and then down 5. So I could say right 3 units and then down 5 units. and then there's no stretching or compressing, and then in this case it says list the vertex and tell if it's a maximum or minimum. This is going to be facing up, okay, because A is positive, so it's going to be a minimum. And we know that that minimum is whatever the y value is, so right here. Alright, so let's do the same thing for this guy. And this was the same graph we just did. So anyway, we know the vertex here is -2, 3. We know that we went left 2 units and then up 3 units. And then as far, again, it's because of the negative, and because of the negative, it's going to be a reflection. All right, and then because of the 2 in front, it is going to be a stretch. Okay, so we'll say stretch by a factor of 2. There you go. Sorry, the handwriting's terrible. I wish it was better. It's not. Okay, sorry. We're just gonna have to deal with it. All right, let's keep going. Now, again, we already talked about this again, the vertex form of a quadratic. Again, inside's always opposite for x, outside's always the y value, and A has to do with the stretching and compressing. All right, and this is going to kind of, again, this is, if you guys want to pause and write this down, again, this is just going to be a little more review of what we've already talked about. Now, here's where we get pretty intense, okay? We're going to talk about writing it in vertex form. Now, in order to write in vertex form, we're going to have to do some completing of the square. Okay, so we're going to completing the square here. So let's do it. Now remember, for the completing the square, we need a b value. So in this case, the b here is -2. So what I'm going to do is I'm going to rewrite this. So it'll be y equals parentheses x squared minus 2x, okay, and then leave some room. And in this case, you see here it's going to be a parentheses, and I'm going to write the +4 on the outside. So we're going to do that again. The b value is -2, so it's going to be -2 divided by 2 all squared. All right. So again, -2 divided by 2 is -1. And then -1 squared is 1. Now, here's where it gets different, guys. So I'm going to add 1 inside. Now, usually you guys are used to adding the same value to the other side. Now, you see we have this y over here. We need y to stay by itself. So instead of adding the same on the other side, I'm going to, so like it would be like +1. I'm going to go ahead and I'm going to subtract it because we need y to stay by itself. So I'm going to subtract 1 from both sides here. Okay, so it's like I'm adding whatever it is to the inside and subtracting that same value on the outside. So I'm doing the same thing, it just looks different. Okay, so again, I'm going to write this as a perfect square, so it'll be x minus 1 squared. And then 4 minus 1 is 3, so +3. All right, I don't have a graph here, so I'm just going to make a graph. So here's my graph. So my vertex is at 1, 3. So 1, 1, 2, 3. And it's facing up. It's going to be like over 1, up 1 for the 1A, and then over 1, up 3. And then same on the other side. So something like this. And there you go. All right. All right. Next one again, and I hate freehand graphing, so I went ahead and I paused and got us a graph. So you're welcome. All right. So here we go. Again, we're going to write this in vertex form. So we're going to do the same thing. So the first thing I want you to do is I want you to kind of separate your terms out a little bit. So this is going to be y equals -3x squared minus 18x, and I'm going to put that in parentheses. And we don't need to leave space yet. And I'll tell you why. So again, minus 22. So you're just kind of separating your c value. So now what I can do is I'm going to you see that both of these terms have a -3 in common. So now it's going to be y equals, pull out a -3, parentheses, a x, change the sign, plus x squared plus 6x. Now leave some space, minus 22. So again, now we can go ahead and complete the square. So 6 is b. So 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to this side. Now again, remember from your completing the square homework, you add 9, but you're not really adding 9. You're adding 9 times negative 3. So so again, on this other side, we would be adding... So we would add the same thing, so it would be like subtracting 27 from this side. But again, guys, we need it on this side again, so I'm going to go ahead and I'm going to add 27 here. Okay, and I'll cross that out now. Again, it's the same thing. I'm doing the exact same thing, but again, I understand it might be a little bit confusing, but just bear with me. Again, instead of adding it to the other side now, we're trying to graph it, so we have to do the opposite sign to whatever to the same side, I guess. All right, we'll do a lot more too. So anyway, so it'll be y equals negative 3. The perfect square will be x plus 3 squared. Negative 22 plus 27 is plus 5. Let's go ahead and graph it. So again, vertex is going to be negative 3 comma 5. So comma positive 5. So right here. And then my a is negative 3. So 1a is negative 3. 3a is negative 9. So I'll go over 1 down 3. And then over 1 down 9, down a bunch. I'm going to run out of space here, so that's okay. I'll just go ahead and graph it like this. Okay, something like that. Super skinny. This parabola has been hitting the gym. All right, let's keep going. All right, so now in this case, you see that I actually don't have a c value, so it's going to be a little bit interesting to start, but we're going to do it the exact same way, but I don't have an initial c value that I need to separate already. So let's go ahead and do this one. So again, I'm going to start. You see they both have a 2, so I'm going to factor out just a 2. Remember, we're trying to complete the square here, so it's going to be y equals 2 parentheses x squared plus 5x. Now I'm going to leave some space. All right, so now again in this case, I know that I'm going to try to find my my b value, so I'm going to do 5 over 2, and I'm going to square that. So 5 divided by 2 is just 2.5, so I'm just going to leave it as a fraction. So it'll end up being 25 over 4. So I'll add 25 over 4 to each side. So now again, when I'm adding 25 over 4, I'm actually adding 25 times 2. Okay, so again, in this case, it's going to be 25 times 2 is 50 over 4. So that will be the same thing as 25 over 2. You're just going to have to trust me on that math. Okay, so again, I'm going to add it to this side. So I'm going to do, it would be plus 25 over 2. And then instead of adding it to both sides, instead of adding it to this side, I'm actually just going to subtract it from this side. So minus 25 over 2. So now that's taken care of. So now it'll be y equals 2 parentheses x squared. Nope, not squared. Sorry, not yet. X plus 5 over 2 squared minus 25 over 2. And that's it. All right. So let's go ahead. I'm going to put, again, we're not going to have a whole lot of room here, but I'm going to go ahead and put this into a in a decimal form so we can deal with it. So it'll be y equals 2 times x plus 5 divided by 2 is just 2.5. So 2.5 squared, and then 25 divided by 2 is going to be 12.5. All right, so I moved my graph so we can actually graph this guy. So again, the vertex here is going to be negative 2.5 comma negative 12.5. So right here, 2.5, 12.5, so right about here. Go over 1, up 2, and on both sides right here. And again, and then over 1, and then up 6. 1, 2, 3, 4, 5, 6. So right here, and that's pretty much it. All right, guys, I'm running out of time. I want to do a couple more. We'll do those in another part. All right, see you in that one.